Hello, welcome back to Sover, the Shape-Shifting Minesweeper. In this video, I would like to go through what went into making this game. If you haven't seen the previous video, this is just a Minesweeper, but instead of just only having rectangles as the grid shape, you can also change it to a hexagon and a triangle. And that also changes the numbers as well, so it actually has an impact in gameplay. I'll try to show an example. Okay, so there are these 5 bombs in a row, and this tile only sees is 3 tiles, but if it turns into a hexagon, then it now sees 6 tiles, and 2 of them are bombs. And if it's a square, then it sees all 8 neighbors and 3 of them are bombs. And that completely changes how you play the game, obviously. And if you watched my previous video on the making of my games, you know that I made a custom engine for all of these. And this was the first time I implemented a grid system. So that's mostly what I'll be talking about in this video. I've made a lot of grids in the past for all kinds of different games, but all of them have always been these square grids. And that's because those are by far the easiest ones to make. And obviously the hexagon ones were the hardest, and I think I've implemented it in a pretty interesting way. Probably how it's normally implemented, but I honestly just don't know. I just went with the first idea I had, honestly. And since this game, I've used grids for a lot more other games. None of them are available yet, because none of them are done, but I can show you an example, for example. Yes. Okay, here's a really simple platformer I made that also used the same grid system. And because it uses the same system, I can change its type. Okay, I opened up the console in the left, in the right, whatever. And the name of the grid is just main grid. If I press enter, I can look at how it's saved in the code. It has a data part and a grid part. The grid part is the actual grid. Okay, that makes no sense. The grid part is what's on the grid, and these have multiple layers. There's the white background, which is called the floors layer, because I didn't rename it, don't worry about it. But the black parts are the walls. So saved in a weird way, but basically the 0 is the left side of the wall and the 14 is the right side. So 0 and 14 always have a wall in them. But the good part is that I don't manually write these values here. In the Minesweeper game, everything is randomized, because the bombs are just randomized and the numbers are calculated based on them. In this game, all of them are generated by this test layout 2 variable. Also didn't rename it yet, sorry about that. But basically just a text that looks like this. And every W is a wall, as you can see. This is the bottom few rows, and the actual grid has the same stuff in it. At the top there's a DT, which are just different color squares. They don't really do anything, but that's a value, basically. And there's also a symbols variable, and that tells you what the different letters mean. So here W is a wall, which is a wall, and a T is a table, which doesn't mean anything. That was just a random word I wrote in it. And okay, I'm gonna reload this 1 second. Okay, I actually loaded up a different game to show that it also works for hexagons, for example. So there's a green player character that I can control, and they can collide with the hexagon walls. And just like that, this character can also collide with any wall. If I change the grid shape to a hexagon, it's gonna be inside 1 second. If I jump and in mid-jump I change it to a hexagon, then I can also collide with the hexagons. It's a bit weird here, because for the collision it only checks the corners, so I can get impaled like this. But other than that, it works perfectly well. And of course, if I want to change it, I can just change the hitboxes to be more accurate. I can change it to a triangle as well. Beautiful. And that's basically the point of all of this, that for this game, I didn't have to do any work to make the grids work, because I already made the grids in the Minesweeper game and I can just reuse the same code for it. Okay, now I loaded up a smaller grid for the Minesweeper. As you can see, it also has a grid. And in it you have all of the bombs and the numbers. So for example, there's this 202, that's these ones, and those are the revealed ones. That's why it says is revealed is true. And the best part about all of this is the data part that I haven't shown yet. I'm gonna do something that I've never done before in the channel, which is actually try to implement a new feature in the engine. As I haven't done yet. I'm doing these recordings way out of order. This is the first behind the scenes video I record. I don't know what I've did in the other ones, but basically you know how there's this square, hexagon, triangle grid. I since then realized that it's also common, not that common, but it also comes up a few times in video games, that there's an isometric view. It's the same as a square, but it's rotated. And I want my engine to be able to do that as well. It's not too important, and I currently don't have a game that needs that to be the case. But since I'm making this video, I thought it would be a nice way to show you how I would go by implementing something like that. But first I would need to tell you how the hitboxes work for the grid. And for that I'm gonna use my beautiful drawing system that also is part of the engine for some reason. I made this for the Nanogram game, and I just put this into other games as well, so yeah, I can just draw whatever I want. And you can as well, by the way, you just have to press the backwards tick button or whatever it is, guys. On the English keyboard is the button that's left of the number 1, and then you can click any number button to change the color and just draw. And it actually stays on the screen unless you press right click while in this mode. Okay, basically, as you can see, wherever I put my mouse, that tile lights up. And that's because it knows my mouse position and it calculates which tile my mouse is in. And it's actually really easy to calculate for a square grid. So you have these rectangles, obviously. There's the top left corner of the whole grid that, let's say, is at 0, 0. And now you have two other values, which is the width and the height of every tile. Let's say that's 10 for all of them. In my engine, I made this so the width of the screen is 1. So this one would be like 0.15 or something like that. But let's say it's 10 for this scenario. And let's say I clicked here, which is at 25x and 5y. And as I said before, the first tile is labeled 0. So let me just label every tile real quick. So this square is 0, 0. This square is 0, 1. And this is 0, 2. And this is 1, 0 and 1, 1. And you can figure out the rest based on this. So it's the y coordinate and the x coordinate. I actually switched them up, darn it. Okay. In the code, it usually goes y and x. But here, when I wrote the numbers, I wrote it x and y. I hope it's not too confusing. I color coded them, so it should be okay. Yeah, basically, you have to figure out somehow that the coordinate 5 corresponds to 0, the 0 square, and 25 corresponds to the second square. And it's actually really easy. You just divide the coordinates by the sizes. You do 25, 25 divided by 10, 2.5, and then you floor the number, which removes the decimal point, so it's just 2. And you do 5 divided by 10 is 0.5, and then you floor that one as well, and then it's 0. And that's all you have to do. Okay, not all you have to do. Technically, before that, you have to do 25 minus whatever this is, where the top left corner is. But here it's just 0, so that's 25. But if it was at 10, you would need to do 25 minus 10, and then divided by 10, so yeah. But basically, this is just a subtraction and the division and the floor. And that's all it takes to know where you click. This is gonna be disorienting, but I'm gonna zoom out. Okay. So even if it wasn't too clear how I explained that, just know that it's very easy to detect where you click in a square grid. And it's worth to know that this is because the whole thing is a grid. So instead of a grid, you would have random boxes, maybe random sizes that are not aligned on a grid. And then I tell you that I clicked here. The only way you'd know which box I clicked in is if you went through all of them one by one and checked if I clicked in them or not. And as you can imagine, that can get really slow for the computer if you have a billion boxes or something. And it would get even more intense if it was a hexagon. I have a function that checks whether a point is inside any shape, but I can't use that for these because then I would have to check every tile one by one whether my mouse is in it or not. And if I have a really huge board, that would take forever. So it would be really convenient to use the same system I use for the square grid for both of these other ones. I'm actually gonna show what I did for the triangle one, and then the hexagon one will come naturally. As you can see, these triangles are awfully square shaped. If you would just draw a straight line in the middle of one and a straight line in the middle of the other and connected them, you see how that's a rectangle. And if you draw another one next to it, it's another rectangle, and you can make a whole grid out of these, and I will, so give me a second. Okay, I did it. So as you can see, you can treat triangle grid as a square grid. And using the same system, I can tell where this point is, for example. I know that it's in this yellow rectangle, but I need to know what triangle it's in. For that, I can just check whether that point is closer to the bottom left corner of the rectangle or the top right corner, because this line perfectly cuts the rectangle in half. And then I just check that this point is in the lower half, and then I know that it's in this triangle. And I colored it in so that every yellow rectangle has this bottom left and top right half, and every magenta one has the opposite, the bottom right and top left. It's slightly more complicated than the square one, but it's still the same thing basically. Except you also have to calculate which half the point is. So even this was pretty simple, weirdly enough. I thought it would be way harder, but since it's using the same system, you can have a triangle grid of any size, and it could still tell you where your mouse is in it with the same speed as if the grid was small. That sentence was so hard to say for some reason. I hope this makes sense. I'm trying my best to convey how I made this, but I don't know what it would be like to watch this video if you didn't already know how something like this would work. Okay, but if you can still keep up, how do you think I made the hexagon one work? Honestly, if you'd like to figure it out, I suggest you pause the video now and have a quick think. Okay, welcome back. Now, as you might have noticed, these hexagons are suspiciously triangle shaped and triangles are suspiciously square shaped. If you take this line and this line, you basically have the triangle grid again. And it's true for these as well. And all of the other ones. Sorry for my random line here, I didn't mean that. So these are just the triangle grids. And in between them there's a square. So you don't have to use any new invention. It is just the same as the triangle one and the square one combined. But how would you draw the squares is the question. The triangle one was kind of obvious, but let's go back to it real quick. And let's say at first it would be like, there's this zero triangle here, and I want to draw a square over it, and I would draw this square. But the problem with that is if I wanted to draw one for this one to the left of it, its square would overlap with this one. And that's why instead of it, we only take half of every one. So if I go back to the hexagon, try to draw those same squares, then you would have something like this. And as you can see, this is a complete mess. This magenta box doesn't actually overlap with the yellow ones. It does overlap with the top and the bottom ones. So if you'd like to divide this hexagon, you would draw a line in the middle. You would draw these boxes and this big box. So these are 4 boxes. And you wouldn't draw the bottom one because just like you don't draw the bottom one for the 3 and the 2 because those are part of the 0, you also don't draw the bottom of the 0 because that would be the top of the 1 and the 2 down here. And actually the way I did these hexagons is that these top squares are exactly half the size of these middle squares. So you can actually draw another line here. Now you have 6 identical rectangles and you can extend these rectangles all over the board. And then you have a square grid. And now you have to calculate which part of the square it is. And if it's the top left, then you have to check whether it's in the top left or the bottom right of that rectangle you clicked in. And if the top right, then it's the bottom left or the top right. So it's the same thing for the triangle, except now we have squares that you don't have to calculate for. And for an isometric one, would just be this kind of rectangle that I could divide the same way as I did with the hexagons. So I would have a top left square and a top right square, and I wouldn't have to check the bottom part because that would be covered by the bottom isometric shapes. Top right and top left. So this should be easy to do, although I made this whole system maybe 3 months ago or something, so it's gonna show whether the code is readable or not based on whether I can read it after 3 months. Usually nothing happens at the first try, so I'm completely okay with this not working right away. Wow. Wow. Yeah, I did forget that it has to be smaller height-wise. So let me add that somewhere. Okay, that works. Wait, wait. That does work. Geez, that looks so weird. That does look really weird. And basically, the point is that if you want the isometric view to be different, you can just change like the height for them. And then yeah, this is how usually isometric stuff work. The hitbox don't work currently, as you can see, but now that I drew them, it's gonna be easier to fix that. Okay, this took a while, but it works now. As you can see, it sees where I'm clicking. Of course, the tags don't work because they still align like the square shape because they use a different function and I didn't touch that yet. But everything else works. The gradient also works, which is really nice. Yeah, and it works now, let's go. And if I would like to, I could set the height to it to be smaller, and then it's very 3D, I guess. This is very cursed, but it works. Again, in the huge grid. It's beautiful, honestly. I mean, do the numbers actually work? Is there one? Wait, does it actually work? I actually didn't test that, but I thought it would. That's what I made sound. But it actually works. Wow. But technically this could be part of the game. It might be too much actually. Now I'm thinking whether I should add a button that could change this to an isometric view, but like, it is different from the square one because it only has 4 neighbors and the square one has 8. Technically you could have more bombs if you have the option to switch to an isometric one. I think I will decide against doing that. Oh yeah, the numbers are wrong now because there's another function that you need to run for the numbers to be correct, and I only changed the grid shape without telling the board to actually change the numbers as well, but that's okay. Now it's the same as the square one but rotated. Wait, okay, that's messed up. No, it's not. Wait, how did this work? I don't. Okay, that was the most confusing view of all time. Whatever. But I did it. There's isometric view now. Look at this. And look at this. It's 3D. It's beautiful. It's yeah, wonderful. Can I make the... Wait, I don't know. Wait. Now it's 3D. It actually is kind of 3D. Wait. It is kind of 3D now. I can see it. What am I doing? I don't know. There you go. Isometric View Minesweeper, let's go. But the numbers are wrong. It's actually really funny. I don't know how the numbers work. Oh yeah, because it's shifted to the left, to the right, or whatever. Isometric View Minesweeper, but you have to unshift the board for the numbers to make sense. I think it's a perfect game, honestly. But yeah, whatever. Yeah, this is how you make the game or whatever. I don't know. Okay, thank you for watching.